In this module, I'll show you how to create an elastic load balancer on the AWS account. So we are going to be creating an elastic load balancer. And in this module, we are going to be making reference to this repository. So you have to come to my GitHub. We're making use of this repository. You come to my GitHub, Devops with Mike, and then you come to repositories and you want to search for the Devops with Mike e-commerce site. So I'm making use of the Devops with Mike e-commerce site. So once you click on this Devops with Mike e-commerce site, you access this repository that has the corresponding information which we'll be using to create this given elastic load balancer. So we have basically the installation script for the first server, which is the user data 1. We talked about user data in our previous module, and we have the installation script for the second server, which is the user data 2. So we are going to use user data 1 and user data 2, create the corresponding servers on AWS cloud, and these are the contents of the server 1 and the content of server 2. Once we create both servers, we are then going to proceed to create an elastic load balancer. So when you come to your AWS console, like we are here, we have to go to the region in which we are working. So you come to region, you want to choose the right region with respect to where you are doing your project. For this hands-on, we have been doing our project in North California. So I'll select North California for the region, and we'll be provisioning all our resources in North California. Now, once in North California, where we have our resources, we are going to select launch instance. So I'll select launch instance to create an instance. Once I select launch instance, I'll give the instance, this for the first server. So I'll call this server 1. I'll call this server 1, and then we are going to select the Amazon Linux 2. We'll be using the same Amazon Linux instance or the AWS Amazon Linux, and we'll be using Amazon Linux 2023. So you give the server a name, server 1. You select the Amazon Linux. We're using Amazon Linux 2023. For the instance type, you can allow the instance type as T2 micro, and then for the key pair, you select the key pair which you created in our previous module, devops in my.key pair. You can use that corresponding to your account, and we are going to be creating all of this in the public subnet. So I'll click on edit subnets. I'll command the VPC. I'll use the Devops in my prod VPC which we created in our previous module, and then allow the public subnet. So I'll use the Devops in my public subnet, and then for auto assign public IP, I'll enable auto assign public IP so that we can have public IP for our servers. For the security group, we are going to create a new security group. We call it e-commerce SG. That will be the name of our security group, e-commerce SG. I'll copy this same name. I'll copy the security group name, and I'll replace this here with the e-commerce SG. And then for the security group rules, we'll have port 22 open, and I'll also add another security group rule to port 80. So we search for HTTP. So I have two security group rules, port 22 for SSH and port 80 for TCP. Those are the two security group rules that we are going to have. And then the only last thing we'll do is you come to advanced details. Under advanced details, come to the user data section, and we are going to be inputting the user data. So you come to my Devops in my repository, you select user data 1 for the first server. So I'll copy user data 1. This is for user data 1. I'll copy the user data, copy it from my GitHub. I'll come to where I'm launching the instance, and I'll paste this user data. So I'll paste user data 1. So summarily, for the first step, you create the server 1, give it the name server 1, Amazon Linux 2023, T2.micro, the same key pair. We created a new security group. It's launched in the Devops in my prod VPC, the Devops in my prod public subnet, and then we're creating a new security group. We call it e-commerce security group. And for the security group, we have port 22 open and port 80 open. We come to my GitHub here, copy the user data for server 1, user data 1, and then we come to the instance where we're launching the instance, and we paste that user data for server 1. So once we put this, we select launch instance. So we have an error. We created a security group. We do not select the source type. So under the source type here, we are going to take anywhere IPv4. So you select anywhere IPv4. Once you select anywhere IPv4, you click on launch instance. So this should launch the first instance. You see creating security group. It's first creating the e-commerce security group, and then after that, it launches server 1. Now we come back to instances. Under instances, we are still going to select launch instance. So I'll take launch instance. The second instance, we are going to call it server 2, and under this we are still going to select the Amazon Linux 2023, and then we scroll down T2 micro. For the key pair, we are going to select the key pair name, Devops in my key pair, the same key pair, and then we click on edit security group settings. For the VPC, we use the Devops in my prod VPC we used previously. For the subnet, we are using the same Devops in my prop subnet, and then for the security group, we will now select existing security group since we already created in our previous module. So we select existing security group, we scroll down, and then we select the e-commerce security group. So we select the e-commerce security group, and then under advanced detail, we click on this, we scroll down, we come to the GitHub repository like we did before, and this time we'll be selecting user data 2. So I'll click on user data 2. We'll be using user data 2 for this hands-on. I'll click on user data 2. I'll copy user data 2, copy the raw file, come back to launch instance, and then I'll paste user data 2. So I can paste or paste and match style. You can delete some of these spaces, or you can allow it as default. So summarily, for the second server, you give the name server 2, you give the instance, we select the Amazon Linux AMI, and then we select AMI 2023, T2.micro, the key pair, Devops in my key pair, give it the instance VPC, the right VPC, and then we select the prod subnet, we give it the security group, we select the security group which we created in our previous module, the e-commerce SG which we created in our previous module. And then for the user data, we come to the Devops in my repository, we click on second user data, we copy the user data here, copy the user data, we come back to our launch EC2 instances, and we paste the user data. Now, as we paste this user data, we click on launch instance. So we launch instance. This should launch server 2. So if you come to instances, you should have 2 servers. You have server 1. Let's refresh this. If you come to instances, you have 2 servers, server 1 and server 2. Server 1 is currently running, which is active. So system check has passed. So if I select server 1, copy the public IP of server 1 and paste in a new tab, I'll be able to access the website. So if I hit enter, I'll be able to access the website that has been created by server 1. So let me refresh this. Let's get back to this. Copy the user data. Let's try to open it in another browser. So I'll come to another browser. I'll open my Safari. So I'll open my Safari. I'll paste the public IP of the server 1 in this user data in this, and if I come to the another browser Safari, these are the contents of web server 1. Again, my Google Chrome actually has issues processing this. If you copy the public IP of server 1, as I've copied the public IP of server 1, I come to another browser. I'm using Safari. You can use Microsoft Edge or any other browser. You open a new tab and you paste the user data and you hit enter, you should be able to access the content. So you see Devops in my e-commerce website. This is server 1, or this is web server 1. We are currently in web server 1, and web server 1 has 3 products. Now we come back to our EC2 dashboard, we refresh. We previously had the details for web server 1, but now we are going to be taking the details for web server 2. So web server 2 has passed 2 on 2 check. So on check server 1, we check server 2, and under server 2, unfortunately, we do not auto assign public IP. So we need to relaunch this server because we do not auto assign public IP. So I have to terminate this instance. I'll come to instance state. I'll terminate web server 2, terminate the instance, launch a new instance. This time we need to auto assign public IP. So I'll give the name server 2. This is just a repetition of the previous steps. That's why I'll do it quickly. I'll select the type T2 micro. I'll select the key pair. Devops in my key pair. I'll edit security settings. I'll select the Devops in my prod VPC. I'll allow the prod subnet. And then of course, I'll auto assign public IP. This is what we needed to do. So instead of it being disabled, I'll select it as enabled, and I'll select existing security group. Come back here, select the e-commerce security group. And when I select the e-commerce security group, I come to advanced details, scroll down under advanced details. I'll come back to the user data 2. I'll copy user data 2 again, copy user data 2, come back to launch instance, and I'll paste user data 2. So this is the same steps we've done previously. Give the name server 2, Amazon Linux 2023, instance type T2 micro, Devops in my key pair, and then you put the respective information, and most importantly, you put user data 2 here. Once you input user data 2, you click on launch instance. This should launch the server 2. So if you come back to our instances, if you click here on instances, if you refresh, you will see the first instance we had server 2, there was no public IP assigned because we do not enable or we do not auto assign public IP, and it's actually terminated. If you now come here to the second server which we launched, server 2, and you look at public IPv4, you see we now have a public IP 4. So we can copy this public IP and access it on our web browser. So I'll copy this public IP. While it's initializing, we can give it a minute for it to completely initialize. I'll copy the public IP of web server 2. I'll come to my other tab. I'll open a new tab and I'll paste I'll paste this IP. So I'll paste the second IP to have access to the content of web server 2. So this is the content of web server 2. Web server 2 has 5 items and it says Devops with Mike e-commerce site. This time it says this is web server 2. The other server we have here, this is web server 1, and it has just 3 items, and you can see we have the different IP for web server 1 over here, and if you come here, a different IP for web server 2. But now we are manually choosing which IP to contain, or we are manually choosing which website will have web server 1 or web server 2. But with the help of a load balancer, we are going to automatically distribute the incoming traffic between web server 1 and web server 2 to host the same information. So for us to do that, we have to first come under our load balancers here. Under load balancers, we are still in the EC2 dashboard. We scroll down on the left and we come under load balancers. So we click on load balancers. Under the load balancers, you'll see how you can create a load balancer for your given applications. Currently, we do not have any load balancer. They say Elastic Load Balancing scales your load balancer capacity automatically in response to changes in incoming traffic. So we use load balancer to manage incoming traffic. Now, we do not have any load balancer, and in this exercise, we are going to be creating a load balancer. But before we create a load balancer, we need to create target groups. Now, target groups help us to group the set of resources that we want to distribute traffic between. In this case, we have 2 EC2 instances we want to be able to distribute traffic between them. So once we are under target groups, we click on create target group here, or you can come here to create a target group. We click on create target group. And when you click on create target group, they say your load balancer routes requests to the target in a target group and performs health checks on the target. So you can route traffic between instances, between IP addresses, between Lambda functions, between application load balancers. But in this case, we are going to be routing traffic between instances, web server 1 and web server 2. So we allow it as route traffic within instances. Now for the target group, we can give a target group a name. So we'll call this Devops with Mike target group, and we'll allow the protocol as port 80, given that all our instances are accessible on port 80. And for the VPC, we are going to choose the Devops with Mike prod VPC. So we are creating this target group in the Devops with Mike prod VPC. And for the health checks, we'll allow all these health checks as defaults. Once we do this, summarily, we choose the target type as instances. We choose the target group name as Devops with Mike target group, and then for the protocol HTTP IP addresses IPv4, we choose the VPC Devops with Mike prod VPC, and then we allowed other settings as default, and we take next. Now once you come to this piece, you need to register targets. What does it mean? This is an optional step to create a target group. However, to ensure that your load balancer routes traffic to this target group, you must register your target. So it's like adding the servers that you want to be managed or you want traffic to be routed to. So currently in this region, we have 2 targets, or we have 2 instances running. So we are going to specify that we want to be able to route traffic to these 2 instances. And for us to do that, we just select the 2 instances by clicking on the checkbox. Again, we checkbox the 2 instances, checkbox 1, we checkbox the 2 instances. And after clicking on this checkbox for the 2 instances, we click on include as pending below. Now as you include as pending below, you now see the 2 instances are targets. These are available instances too, and we've added the 2 instances here as targets. So as you add these 2 instances as targets, summarily we tick the checkbox for these 2 instances, and then we click on include as pending below. Once you add them as targets, you click on create target group. So this should create a target group for the instances. You now see successfully created the target group Devops with Mike. Anomaly detection is automatically applied to all registered targets. Results can be viewed in targets tab. So summarily, this is a target group Devops with Mike TG, specifying Devops with Mike target group. It currently has 2 targets corresponding to the 2 instances which you've enrolled in this target group. Currently, it shows you 0 instances healthy and 0 instances unhealthy, 0 unused. This is because it's initializing, and 0 draining, meaning that no instance is being decommissioned. So if you refresh this tab, when the instances have been fully registered as targets in this target group, you should be able to see the current instances that are being managed within this target group. So if you scroll down here, you now see these are the registered targets. We have these 2 targets, and they are currently unused because we'll not be able to route traffic yet to these servers. So once we have these 2 servers as targets, the last step which we are going to do is to come under EC2 dashboard on the right, and here we are going to click on load balancers. So currently there's no load balancer in our account, So for us to create a load balancer, we have different options. You can click here to create a load balancer, or you can equally click here to create a load balancer. Either ways, if you click, it will take you to the spot where you are creating a load balancer. Now you can either create an application load balancer, a network load balancer, or a gateway load balancer. They all route traffic based on the type of traffic which you want to route. If you want to route traffic between application at the level of the application layer, you can use an application load balancer. If you want to route traffic at the level of the networking layer, you can use a network load balancer. If you want to route traffic between different gateways, you can use a gateway load balancer. So in this case, because we want to route traffic within or between applications, we are going to use an application load balancer. So I'll click on create under the application load balancer. So they ask first for the load balancer name, so I'm going to give the name Devops with Mike application load balancer, ALB. So Devops with Mike application load balancer. Now they ask you, do you want this internet facing or do you want it internal? That's, you want to route traffic to resources over the internet for people trying to access this load balancer over the internet. I'll specify that I want to route this traffic for people who want to access this over the internet. So I'll select internet facing, and under the load balancer IP, I'll select IPv4. And now for the network mappings, I'll use this load balancer in the same Devops with my prod VPC. And once I select the Devops with my prod VPC, I'll select the AWS region or availability zone corresponding to this particular load balancer, where we had our resources just in one availability zone. That is why I'm selecting the US West 1A availability zone, because we created just one availability zone. And then after that, I'll select the security groups. There's a default security group, but I'll be using the EC2 security group which we created when we were creating those instances. You can uncheck the default. We are going to be using just the EC2 security group which we created when we were creating the instances. For the listeners and routing, they say a listener is a process that checks for connection requests using the port and protocol you configured. So we are saying that if traffic comes to our load balancer through port 80, we want to route this traffic to this given target group or to this given target resources. So that's why we see the listings on this HTTP protocol on port 80 is currently listening on this protocol on port 80, and then it forwards the traffic to, that's where we are going to select our target group. So if you click here and you select target group, it's going to be forwarding the traffic to this target group. So first it comes to a given protocol on a particular port, and then we forward it to this target group. So once you have this HTTP protocol port 80 and you forward to this target group, and then we can allow these others as default. You could add some load balancer tags. At this moment, we don't need some extra tags. We allow the cloud front, we allow the web firewall, we allow the global acceleration. These are just defaults. We can see them in advanced modules. So summarily, to create a load balancer, you give the name Devops with my application load balancer. It is internet facing, IPv4. You give the VPC, the Devops with my prod VPC we created in our VPC module. For the availability zones, we use the availability zone which we also created in our VPC module. And then for the security group settings, we select the Devops with my e-commerce security group which we created when we were creating both instances. And for the listener, we explained that traffic comes through the HTTP protocol on port 80 and is routed to our target group, which contains our instances, and then we allow all of this as defaults, as these are advanced settings. So as you have these basic configurations, you just need to click on create load balancer. And if you have any information which is missing, there must be at least two subnets, or two subnets must be specified. So we need to add another subnet to our VPC. So I'll duplicate this tab. I'll right click, duplicate this tab. When I duplicate the tab, I'll go to the VPC console. They say we need two availability zones. So I'll come to my VPC console. I'll search for VPC. We added VPC under favorites here. So I'll click on VPC. Once we get to the VPC console, because we are trying to create a load balancer, they say we must have at least two subnets must be specified. We have currently selected just one subnet. So we need to add another subnet. We could select the Devops with my private subnet as well. We have just the Devops with my prop subnet. So they say we need at least two subnets. The two subnets is basically because we need the resources in two availability zones. They say select at least two availability zones and one subnet per zone. So we need to customize our VPC to have two availability zones. So if I come under our VPC console, we'll come to subnets. We can select the Devops with my subnet. We come to actions, and under actions, we can edit subnet ID. Of course, we could enable auto assign public IP for this subnet. We save this subnet. Now we're just going to create another subnet. We can create another subnet. So we click on create subnet. We select our Devops with my prod VPC, and then for this subnet, we can give it the name Devops with mic stage subnet, Devops with mic stage subnet. And for our VPC CIDR, we can give the CIDR 10.0. maybe .1.0. This should be .2 rather, .2, since the other subnet already took that IP, 10.0.2.0/24. And then we click on create subnet. So let's see, a new subnet has been created. Let's see if its provision is still in the same availability zone. Let's come here, select at least 2 availability zones. We need to come to this subnet and look for a way to change the availability zone of this subnet. So we can come to the VPC. Let's see if we can add it here. So we come to our VPCs. Let's click on your VPCs. Let's select the Devops in my prod VPC. Let's edit VPC settings. We have enable DNS resolution with safe. Let's come back to our load balancer tab and then we refresh this, or I'll refresh. Under the default, we have US West 1A and US West 1C. We are not creating a load balancer in this default VPC. So let's come back to our VPC. So if you come back here, we see our Devops in my prod VPC still has just one availability zone. So if you come back under network settings, we'll delete this test subnet since it was created in the same availability zone. So I'll click on actions, delete the subnet. I'll type delete. I'll delete the stage subnet, and then we are going to recreate it, specifying a different availability zone. So for us to specify a different availability zone, I'll click on create subnet. Under create subnet, I'll select the VPC Devops with mic prod VPC. Once I select the Devops with my prod VPC, I'll give it the name Devops with my stage subnet. And then under availability zone here, we are going to select a different availability zone. Our other resources are in US West 1A. So I'll select US West 1C. And when I do that, I'll give the same side that we gave previously, 10.0.2.0/16. And after that, I'll click on create subnet. So summarily, we are selecting the prod VPC. We are giving the name of this subnet, the stage subnet, and then we use the availability zone US West 1C, and we equally select the CIDR, the respective CIDR for our subnet 10.0.2.0/16, and then we click on create subnet. So they say it overlaps with CIDR block slash, so it has to be /24, sorry, 10.0.2.0/24. Once you have that, you click on create subnet. So this will create our stage subnet. Once it creates our stage subnet, you see we have actually created a Devops in mic stage subnet. If you close this, you see we have the Devops in mic prod subnet, dev subnet, and the stage subnet. So let's come under creating an application load balancer. We are going to refresh this. We select the Devops in mic prod VPC, and when we select the Devops in mic prod VPC, you now see we have the possibility to select 2 availability zones. So we can span it across availability zone A, where it will be this Devops in my prod subnet, and across availability zone C, which should be across the stage subnet. So that's how we specify the 2 subnets. The first one is the Devops in my prod public subnet, and the second is the Devops in my stage subnet. So once you select these respective availability zones, under the security groups, we are going to cancel this security group and we'll select the Devops in my e-commerce security group. So we select the Devops in my e-commerce security group. We've already seen this previously. We have all our respective settings. The Devops in my target group, we already saw this. So we have made just one change. We maintain the name of our load balancer, internet facing. Only under the networking settings did we add a new availability zone corresponding to a new subnet that we created. Once you have all of these, you just need to click on create load balancer, and if all your configurations are correct, you see successfully created load balancer Devops in my ALB. So you give you some details for this load balancer. This is a load balancer ARN. You always want to think of load balancer ARN, and equally the load balancer DNS name, the domain name for this load balancer. If you want to access this load balancer, you access it using this DNS name, and you can refresh to know if the load balancer is active or running. So you see the load balancer is still provisioning. So they say it might take a few minutes for your load balancer to fully set up and route traffic. Targets will also take a few minutes to complete the registration and pass initial health check. So it will take some time for the load balancer to initialize using this. So in the meantime, if you come to target groups now and you select the Devops with Mike target group, and if you refresh this, you will see our Devops with Mike target group is linked to a load balancer. Let's scroll down. If you see targets, these are the two targets. Health checks, EC hasn't sent any health check yet. Once the load balancer is active, the target group will now have those targets, or will now have those two instances registered as targets. So summarily, the name of the load balancer, the DNS name, the state is provisioning, is in this VPC. These are the two availability zones. This is the type application load balancer. And if you see, click here for us to get more details. You see the status is still provisioning, and this is the DNS name. So for us to access this application load balancer, we copy this DNS name, we come back to a new tab, and then we press enter to enter a new tab, and we paste the DNS name here. So paste the DNS name. Once I paste the DNS name, I'll hit enter, paste the DNS name of the load balancer. Again, this is the DNS name. The instance or the load balancer is still currently provisioning. If you refresh this, you'll see the load balancer is still in the provisioning state. If the provisioning state is completed, you move to the completed state, where you now have the ability to access the information that is found in your respective targets when traffic comes to your load balancer through the port 80. So if you come here, our load balancer is still in the provisioning state. The reason why we cannot see any information here. So let's refresh to see if our load balancer is accessible. So after waiting a few minutes, we see our application load balancer is currently active. It's now active. If we copy the load balancer DNS, we come to a new tab, or we can already access it here. So you see this is the load balancer DNS. I can still paste the load balancer DNS here, and we hit enter. We can delete all the other tabs. These are the other tabs which we're accessing the instances individually. This is the first tab. We access the instance on 5253. This is the other one, the same 5253. This was the other one, 54241 for the different servers. But if you use an application load balancer, you see if you refresh, it's currently being served data from web server 2. If you refresh here, it's still serving data from web server 2. If you refresh again, you keep refreshing, the application load balancer is saving data between the various web server targets, web server 1 and web server 2. So let's keep refreshing till the sticky session expires. It's not switching. Let's come to our previous web server 1 and we refresh to be sure our web server 1 is active. Web server 1 is active. You come back to our load balancer, we refresh our load balancer, we paste the load balancer DNS again. Let's hit enter, we refresh. Now the load balancer is serving us content from web server 1. So previously it was serving us content from web server 2, but if you keep refreshing, you will see it has switched from serving content from web server 2 to serving content from web server 1. I think if you refresh again, it has come now to serving content from web server 2. If you refresh again, it is serving content from web server 1. You refresh, it's serving content from web server 2. So it's currently routing traffic between web server 1 and web server 2 based on the configurations which we have for the load balancer over here. So summarily, we have been able to come to our AWS console. We first created two instances, web server 1 and web server 2, which contain some user data which we collected from a Devops with Mike repo. We created two web servers, web server 1 and web server 2. We have two instances running. We have our web server 1 and web server 2. After creating those two instances, we came to target groups. We created a target group where we called it the Devops with Mike target group, and under this target group, we registered, this is the Devops with Mike target group, we registered our targets, two instances, server 1 and server 2. We registered them as targets for our target group, and after creating the target group, we came under load balancers, and we were able to create an application load balancer. Create an application load balancer, and the listener, if you check the listener, it forwards traffic to our Devops with Mike target group. So that's basically how an application load balancer and load balancing works. In our next module, we are going to wrap up with auto scaling groups.